Hello. So this this is probably going to be a relatively short one, but we're going to be focusing on what is a linear equation in two variables, why it has the name linear equation, how to recognize what it is, and then solutions to these things. So what is a linear equation? Have you ever actually thought about why we've been solving linear equations and how they got the name? Because we've been solving for x first half of the class, and they were all linear equations. 2x plus 5 equals 10, that's linear. Why is this called a linear equation? Well, it's because when you graph a linear equation, you get a line. So the word line is literally in the name linear. It's just telling us that this forms a line when we graph. So why do we have linear equations in two variables when we've been working with one variable, x, this whole time? Well, it's because of graphing. When you're graphing, you've got two dimensionals. You've got your length and your height, or your x and y, and so we need two variables. We call things 3D when they pop out of the screen and stuff like that, because there's three dimensions, length, width, and height, basically. And so we have x and y, and we already were using x. Y is just the next letter in the alphabet, so that's why our variables are x and y. But we need to have two variables in order to graph, hence linear equations in two variables. So you basically, if you have a linear equation in two variables, when you graph it, you get a line. Now you can graph linear equations with one variable on a 2D graph. Like everything that we saw with just x, you can still graph that on something that's 2D. It's just going to look different than most of the types of lines, because basically if you have x and y, your line is slanted, but if you have only x or you only have y, it's either vertical or horizontal. So it's still a line, it's just a special type of line. So putting this all together, we are looking at linear equations in two variables for this week. And so we have a specific definition, as of course we always do. And so to have our standard form, the form that we write these things, let A, B, and C, so these are constants, they're real numbers. It just means that they're numbers, positive, negative, whatever, but they're numbers. And A or B are not both 0. So the reason why A and B can't be 0 is because if they're 0, one of the variables disappear. So if both are 0, we have no variables, because those are the numbers that are in front of the variables. So that's why they cannot be, we can't have both of them be 0. We can have one of them be 0, just not both of them. So that's why that is in our definition. So our standard form of a linear equation in two variables is ax plus by equals c. And we use a, b, and c for these constants. Capital letters are to show that they're different from variables, and then just alphabetical order. I mean, that's basically where this equation came from and how they chose the letters that they chose from. So that is what's called standard form. You basically have an x and a y, they're on the same side of your equation. And if you see that, it's going to graph a line. And so being able to recognize that something's in that form is really powerful, because you know what it's going to look like. There are two additional forms of a line. That actually should be a b. So we've got y equals mx plus b. This is a special type called slope-intercept form. But if you see something that looks like that, it's a line. And then we also have y minus y1 equals m times x minus x1, and things like that. They're automatically lines. So let me kind of show you some examples here. So if in our standard form, that would be something like 2x minus 3y equals 6. If you see something that looks like that, it will give you a line when you graph. So I've actually got a graphing calculator open. Let me pull that up. So this is a website that you're going to be using this week on your discussion, and you're going to use it next week with some graphing as well. It's called Desmos, D-E-S-M-O-S. Desmos.com. It's wonderful. I would definitely use this instead of trying to graph things by hand, though graphing by hand does help you learn. So I'm just going to click on Graphing Calculator. And so this pops up. So in order to graph an equation, you type it over here. So it's already got my cursor there, and I just literally type what I see. So that the equation that I wrote was 2x minus 3y equals 6. So I just use my keyboard to type what I see, type the equation. And so you can see that that gave us a line. This is what the graph looks like. So this is why it's a linear equation. It gives us a graph. So let's look at these alternative forms, like the y equals mx plus b. So a graph in this form would look like y equals 1/2 x minus 1. So that is something that is still a linear equation. It's just in this different form. So I can go back to my graphing calculator and graph that. So if I want to turn off the one that I just graphed, I just click the colored circle, and then that turns it off. So it's, you can see on the left right next to my equation. My cursor's not really showing up, but I click that, it turns off. And then I click below it and I can type my next equation. So y equals, and then you're probably wondering, well, how do I do fractions? So you can do the fractions the same way you do it in Connect Math. You can use /, which is the keyboard shortcut for a fraction. Or if you go to the bottom here, bottom left, there's this keypad, and there should be a fraction button, I thought, somewhere. Maybe there isn't a fraction button. I thought there was a fraction button. Well, a fraction is basically division. So when you're typing it in, you can hit the division button and that will form a fraction. If you hit that first, it actually puts the fraction in there for you. So our equation is 1/2, and then I need to move over and put my x, and then it was minus 1. So this, again, it looks very similar to the other equation that we have. They're not exactly the same. I can graph them both at the same time. You can see they're color-coded. But again, that gives us a line. It's just a different form of a line. And you can see that when I was starting to type things in, it already started trying to graph it or figure out what I was doing. You know, first when I just had y equals 1/2, it was like, oh, that's a number. And then it was like, oh, you've got a variable here. So it tries to figure out what you're doing. But the point is, this is another type of a line. So if you see equations that are in this form, you know, the numbers might be different, but the variables are in the same places. The signs might be different, but if it looks like that, that's going to be a linear equation. Now, the third format we have is called point-slope form. And this is the form that I recommend that you use in your discussion for this week. But an example of seeing what this might look like would be y minus 2 equals negative parenthesis x plus 5. So that would be what something in this form would look like if it was in point-slope form. And it's still considered a linear equation. So let's graph this in our graphing calculator. So I'm going to turn off my other graph and then go on a new line. And you can see because I expanded this button, it automatically expanded, but I can close that again. So I just type in y minus 2 equals negative parenthesis x plus 5. And so you can see that again, in this form, we get a line. So if you want to just play around with this website and say, okay, what do these equations look like that form a line? You can just make up your own equations using x and y and putting the x's and the y's in different spots and try to figure out for yourself what makes something linear, you know, and try to learn what equations that have both x and y make lines when you graph. So that's why these are linear equations. They form lines, and these are the forms that their equations can take. And Previously, when we've talked about linear equations in one variable, we have talked about solving them because we solve for x. Well, here we have two variables, so what are we solving for? We don't really solve these things. We usually just graph these things. So if you did try to solve, there are technically infinite solutions that can work in these equations because you've got numbers for both x and y. So there are technically infinite solutions. So we don't really solve, we just graph, and the graph is a visual of the solutions. Sometimes you will see them say solve this equation for y, and all that means is try to get y by itself, and then you're not getting a number. You're going to still have your variables. It's just not going to be a number as your final answer, like if we have one variable. So that's the difference between something with one variable and two variables. Is one variable you can solve for a number. Two variable you solve and you still have variables in your equation. You can't really get rid of them. So how do you recognize that something is linear? So it's linear if one or more of the following hold. So if you put it into, a graphic calculator, it gives you a line. Okay, it's a linear equation. Obviously, if it's in one of the forms that I put on the previous slide, but you can look at an equation and basically figure it out without even graphing it. And the rule is that there's no exponents on your variables after you do your simplifying. So I have two examples here. One is linear, one is not. So 2x minus 3 equals 5y is linear. There's no exponents on the x and the y. Now, the example on the right, 2x times x minus 4 equals 6y, looks linear because currently there's no variables on anything, or no exponents on the variables, I mean. But when you multiply it out, and that's what we mean when you simplify each side, which means you need to multiply it out, we got 2x times x, which is x squared. And then 2x times negative 4 is a negative 8x equals 6y. So when you start simplifying, we now have an x with an exponent of 2, which means it's no longer linear. Actually, that exponent 2 is quadratic. We talked last week about how to recognize whether something is quadratic, and that's when it has an exponent of 2. So something is linear if there's no exponents. So that's the difference, but you do have to try to simplify these things to determine what is it going to look like, and then that will tell you if it's or not. So I just have a couple examples here because the focus on this was basically what is a linear equation and then how do you know it's linear. I want to talk some about the fact that there are infinite solutions because we're not really solving, but you'll be asked to determine if something is a solution. So we're given an ordered pair here. We're told to determine whether the given ordered pair is a solution to the linear equation. So the ordered pair we're given is 8, 2. Now remember that the variables are in alphabetical order. So the first one is going to be x, and the second one is going to be y. And then we're given an equation, x minus y equals 6. So to determine if it's an ordered or if it's a solution, you plug those values into your equation, follow the order of operations, and see if you get a true statement. So we're going to plug in 8, 2 into the equation. That is how we're going to determine whether it's a solution. So instead of x, our x value is 8. And then instead of y, our y value is 2. So I have 8 minus 2 equals 6. And then I simplify. So we're following the order of operations. 8 minus 2 is indeed 6. So we get 6 equals 6. And then basically is your determination. So we got something that's true. 6 is equal to 6. So this means, yes, it's a solution. So a solution, as we've learned in the past, means that when you plug it in, your equation comes out true. So here we plugged this in and our equation came out true. So we have the solution We have two numbers. We have an x and a y value for our solution. Now, I said that there are infinite solutions to this equation. So it says find other solutions to this equation. So the way that we usually do this is to pick a number, any number that we want for x or y. So let's say we pick a number for y. And you can pick any number you want. Don't pick 2 because we already did 2. So the easiest one is say like y equals 0. Because if you set things equal to 0, they're really easy. So then you plug that into your equation. So that gives us x minus 0 equals 6. And then we solve. So x minus 0 doesn't do anything, so we end up with x equals 6. And this gives us a second solution. We write it as an ordered pair, 6, and then our y value that we plugged in was 0. So we just found another solution to this equation. Now you can do this as many times as you want because there's infinite solutions. So I can pick a different number for y. I can do y of 0.5 or 1 or pi. I can pick anything for y that I want. And if I plug it into the equation, I'm going to get its matching number for x. There's always going to be an answer when I plug it in. There's always going to be a number. So there are infinite solutions. And generally you can't find them all because there's infinite numbers. So you just pick one, or maybe you find 2 or 3 solutions. So I'm going to bring out the graph again, and I'm going to graph this equation, and then I'm going to show you that these are solutions. So I'm going to hide that graph. So I'm going to graph our line y, or x minus y equals 6. So that's our line. And any point on that line is a solution. So we tested whether 8, 2 is a solution. And you can even put that in here. You can write in ordered pairs, 8, 2, and you can see that it puts it on the graph. And if it touches your line, that means it's a solution. I can even name it if I want. I could name it solution. Now we solved and we found 6, 0. So I can do that and you see, okay, that's on our line. That is a solution. So I can call it a solution. Anything on this graph is a line. So one thing about Desmos is if I click on the line, it automatically puts a point, and I can click and drag it. So any of these numbers here that is listing me, any of these ordered pairs, these are all solutions to the equation. And so you can see that there are infinite solutions because this just goes on forever in either direction. And I can zoom out and it will keep going. It never ends. So there are infinite solutions, and we just have found 2 of them. But there are many, many, many more. So let's take a look at this one right here. It's the same thing. We're given an ordered pair and equation. This equation is in one of the other forms that were given, but it still forms a line. And we want to determine whether 3, 4 is a solution. So I'm going to do that in yellow, just like I did on the previous example. So first I'm going to replace the x and the y with 3 and 4. So this is telling us that x is equal to 3 and y is equal to 4. It's alphabetical order. So instead of our equation where I have y, I'm going to put 4. Then I have negative 1/3, and then in parentheses, that's multiplication. I'm going to be multiplying it by our x, which is 3, and then plus 3. So we need to follow the order of operations here to see if this comes out to something that's true. So I have negative 1/3 times 3. So when you multiply those out, you get negative 1. So that's negative 1 plus 3. And then a negative 1 plus 3 is 2. So we have 4 equals 2, which is false. That's not true. And so if you get something that's false, it's not a solution. So it's something it's not a solution because it doesn't work. When I plugged it in, we got a false statement here. So now let's take a look at finding a solution. So this was not a solution. And welcome, William. So hopefully you got my email that remind is down. I did get going, and this is actually my last example. So it might be best to watch the recording when I post that, but you can hang around. Technology was not working today to remind people. So what I did here is I just tested whether 3, 4 is a solution to this equation, this linear equation. We found that it is not. So we want to find other solutions. We want to find something that is a solution. So we know that 3, 4 doesn't work, but maybe 3, something else works. Or maybe 4 with y equals 4 works. Maybe it's a different x value. But in order to find a solution, you want to pick a number for x or y, and you can pick any number that you want. So let's do x equals, and you're probably, how do I pick a number? 0, picking 0 is always easy. Or if you've got fractions, pick numbers that you can divide by that fraction. Like I want to pick something that I can divide by 3, because that way you avoid having to really work with fractions. 0 is really easy. Let's do x equals 6. So I want to pick something that I can divide by 3 because we've got that fraction there. So I can pick any x. Actually, let's do negative 6 just because we can, just to do something a little different. So I'm going to plug this into our equation. We have y equals negative 1/3 times negative 6 plus 3. So we want to follow the order of operations. And so a negative times a negative is a positive, and we will get 6/3, because a whole number always gets multiplied with the top number, and 6/3 is 2. So this is y equals 2 plus 3, which gives us y equals 5. So we have found a solution that when x is negative 6, our y is 5. And so that is a solution for this equation. 3, 4 was not a solution, but negative 6, 5 is. So I'm going to bring up our Desmos, our graphing calculator, to show you this. So I'm just going to turn off all these other things. It still has the label, so I can actually hit X, and you can see that they completely disappear. So I'm going to type in our equation. Y equals negative 1/3, third x plus 3. So this is what our equation looks like. And our equation, or our question was, is 3/4 an ordered pair? Is that a solution? So if I type that in, you can see that it is not on the line. So that's why it's not a solution, because it's not actually on the line. So anything that's not on the line is not a solution. Points that are on the line are solutions. So I can even just label this not a solution. And that's what we found when we plugged it into the equation. It didn't work. But we did pick a number. We picked a number for x, and we picked negative 6, and we got 5 out. And you can see that that is on our line. You can see that it shows up here. So I can say, okay, that is a solution. And so 3/4 was not a solution, but if I look on my graph here, and I'm very careful about how I move my mouse, I can get to 3. The real solution is 3, 2, not 3, 4. So if we had picked x equals 3, you would have gotten y equals 2 as your solution. And then any number on this line is a solution. And we usually like to pick ones that are whole numbers because they're a lot easier. Like if we had picked x equals 0, we would have gotten 3 out for our y. And we don't have to pick numbers for x. We can pick numbers for y. I could have picked y equals 3 and solved and gotten x equals 0. I could have gone over here and picked y equals 0 and gotten x equals 9. The point is, when you're finding solutions to a linear equation in two variables, you can pick any number you want for one of the variables, and you'll always get a solution when you solve. And that's very different from when we had linear equations in one variable, because in one variable, you don't get to pick anything. You get one number, and it's always that number. But solutions for linear equations in two, you have infinite solutions, and it depends on what you pick. So that's basically what linear equations in two variables are in a nutshell, and what solutions mean. Generally, what we do with these is that we're graphing them because graphically they mean something. Usually, I mean, you see lines all the time used for predictions, and so that's usually what we do with these things. Once you get into higher levels of math, you will be graphing multiple lines at a time and looking for where they intersect, and those are called systems of equations. And those are used a lot as well, especially if you're going into engineering, you solve a lot of those. So once we start getting into two variables with x and y, the focus is on graphing instead of solving, which is what we've been doing so far.